Today we're building a cassette system for a fiddle yard. Hi everyone, I'm Martin and welcome back to Donnington Castle Model Railway. Now, for those of you who are regular viewers of the channel, you may be a little bit surprised in what we're doing in this episode, being that there is no fiddle yard here on Donnington Castle. So why are we building a cassette system for a fiddle yard? Well, there's two real answers to that. The first is that as a member of Newbury Model Railway Club, when we were building our Lambourn layout recently, we had need to design from scratch a fiddle yard for that layout, and that was kind of really the kind of main criteria for learning all about these kind of things. But the second thing is that if there is ever an extension to this layout, then some kind of fiddle yard is a distinct possibility, and given the lack of space that there'll be if that ever happens, a cassette system might be a useful thing to understand a bit more about. So it's really a win-win situation here. We get to build a cassette system for a fiddle yard on a new layout. We also get to learn a lot more about the engineering involved in these systems, which might then be useful for this layout in the future. So the important thing on any project, particularly when you're starting from scratch like this, is to really think about what are the requirements of the system that you're going to build. So let's start out by looking at the design requirements for this system. Now, every situation is different and every layout is different, and certainly if you walk around any exhibition you'll see a huge array of fiddle yards, and in some of those cassette systems that are in use. So what's going to be the right solution for the layout that we were building? Well, before we started out we really made a kind of a decision to focus on 4 key design requirements, and I'll talk through those because these are the things that are going to guide us through the rest of the design and the build process. So the first of these is cost. We're a very small club, we don't have a lot of money, and therefore we couldn't really go and buy a more expensive off-the-shelf solution for what we were looking for. So we had to think about building something that was very cheap. But that also leads on to the next requirement, and that is that the system also needs to be very easy to operate, and by that we also mean needs to be reliable. Now, when you look at a lot of cassette systems in use, there are some real wonders of miniature engineering. The downside to that is that anything with any complexity takes a long time to design, it takes time to build, but then also to test and refine and get working reliably, particularly if you're going to rely on that when you're running trains at an exhibition. So one of our criteria was therefore that this was going to be as simple as possible. And that simplicity would hopefully bring with it reliability. So that was certainly another key consideration. And that kind of leads into number 3, which is then this also has to be easy to operate. Anyone who's been at an exhibition operating their own layout will know that there are lots of different pressures. You have a pressure to run trains on your layout and to keep the people coming to see it entertained. But at the same time, you're usually having to deal with questions from those very same people. People who are interested in the layout, people who are interested in kind of how things work behind the scenes. And therefore having a system that is as simple as possible, enabling you to focus on running trains and engaging with the people who come to see your layout is really important. And then the fourth thing that we had to consider was the amount of time that it would take to build this. We were building a layout at the same time as we were building the fiddle yard, and therefore we didn't have a huge amount of time and resources to devote to this, which lends itself to that idea of simplistic design and a reliable design. But also we wanted to try and make this as kind of scalable and extendable as possible with the least possible effort. Therefore, if it was going to take us months to build one single cassette, then if we needed then, for example, 10 cassettes to run at an exhibition, then that just wasn't the kind of scalability we were looking for. Now, with various tools and bits of automation, there are ways that we can really work around some of that. But those are our kind of 4 key requirements for the design. And those were things that we kind of took right into that process. And that's a process that I'm going to go through with you now. We're going to look, first of all, at the design process, building the cassettes and looking at how those would actually work within a fiddle yard context. Then we'll go through building those, some refinements to them, and then looking at how those operate on the actual layout itself. Hopefully ending up with something that is easy to use and creates a great experience for visitors who come along to see the layout. If we get all that right, then at the same time we'll also have learned something about cassette systems, their design, and some of the engineering behind them, which we can use going forwards in other projects. So let's nip over onto the computer and start looking at some of our initial design concepts for this system. Right, here we are in Tinkercad. For those of you who are regulars on the channel, you'll have seen this before. It's free, online, and very easy to use CAD software. Now, the beauty of CAD software is that you can create a 3D representation of the thing that you are building. In this instance, everything you can see here is all flat on the work plane. That's because it needs to be in that state in order to export it ready for laser cutting. But what you can see here are the various pieces that are involved in this. We've got a base. To that we are going to attach two sides, which we've made with a little handle to pick up. And you can see us rotating that, so if you can kind of rotate and then move that just to check that everything lines up. So better to do that before you move over onto the laser cutter. But you can see here how it's really easy to move the pieces around and just make sure that you've got all of the kind of the notches and the joints in the right place. Okay, so hopefully by this view you can start to see how our cassette's going to look. This is all going to be cut from 5mm plywood. But as you can see, we've got little notches that then fit into the base, and we can then use some wood glue to fit all that together. You just see me here duplicating that side just so you can get a better idea of what that is going to look like. There's also a 2D and a 3D projection view on Tinkercad, so you can use these interchangeably to help with design and then also to help visualization. What you'll see here is a spacer that we've got. These will then keep the whole thing square and give some rigidity, but also keep the weight down as much as possible by having cutouts in these things and also allowing us to see what's in there much easier. Okay, so let's put all that back to how it was so we can export that for the laser cutter. You'll see here some extra pieces. We've got some spacers that are going to be used on the baseboards. These are little doors that we're going to put at the end of the cassettes. Now these are going to be 3D printed. So the great thing about Tinkercad is we can export to SVGs for laser cutting, but we can also export to STL files that we can import into a slicer like Cura. So this is effectively our door system. These are going to go on each end of the cassette. That means that when something's in there, we can just drop a door in and stop that sliding off. Keep things nice and safe as we move the cassettes around. You can see here how we can rotate, just to give you an idea about how that door is going to look. And that's obviously then going to slide up and down in that piece. But we'll export all of that onto and get that sliced and 3D printed. Obviously we're going to need 4 of the grooves for each cassette and then 2 doors for each one as well. The doors are slightly shorter because they are going to sit on the track, and the track is obviously going to be probably about 5mm up from the base of our plywood. But again, you can see here just how easy it is just to duplicate pieces and just kind of check that things are going to work for you. As you can see, that's how the door is going to kind of slide in and out of that on the finished item. You will see a roundabout on the work plane on Tinkercad that we've got various sizes of piece. So the great thing here is you can create a design and then alter the size of that for different locos very easily. Here you can see how easy it is to export. So this is just exporting to STL files. And again, as I said, the pieces for the laser cutter, again, you can just go to export, but pick SVG files and then import those into Lightburn. So you can see here that we have the way we create our pieces is effectively to use kind of shapes and then cut out shapes. Then by grouping things together, those cutouts can then effectively kind of make holes in things. So it's very easy to kind of build up quite complex objects using the very basic shapes that come with Tinkercad by default. But let's get that exported and let's have a look at that in the next stage of the process. And here we are in Lightburn. So all that we've done is now imported those SVGs that we exported out of Tinkercad into Lightburn software, which you'll have seen a few times on the channel already. We can then lay these out on our cutting grid, select the cutting profile. In this case, we're using 5mm plywood cutting profile. No engraving or anything like that on these objects, so they are all going to be marked in the same colour. And then what we can also do then is get things lined up so that we can cut everything, nest everything together and minimise the amount of waste. So you can effectively snap to grid in Lightburn, or if you want, you can zoom in and just kind of make sure that things are lined up to within enough tolerance. Obviously, the laser that you're using to cut has an actual beam size, so you're not going to get an infinitely thin cut. You're always going to get a certain amount of cut distance. In this instance, with the Falcon 2 laser cutter and using these materials, nesting things together like this and just cutting once around them, you will get a very good fit. That gap is not significant, and therefore we don't need to worry too much about that. But as you can see here, what I'm doing is importing the pieces one by one, just building up an individual session. We can then save this off to a file, meaning that whenever we want to cut a particular cassette, we just open the file back up, put our wood on our laser cutter and hit play, and that will then effectively produce us another set. Here we are importing some more spacers. So we want to try and get as much on this particular piece of wood as possible. So that sometimes means rotating things and just kind of getting things lined up. There's always going to be a little bit of waste. There are online programs you can use to nest together these pieces to save you having to do it manually. And we use different algorithms to then figure out what is the most efficient way of putting things together. With some of these objects, it's not so important to do that. We're not doing this commercially. The amount of waste is minimal. If you are working commercially, then those programs are really good to really obviously maximise the profit that you can kind of make out of different pieces of material. I actually find that a lot of the offcuts I use are very useful in other aspects of the railway. So particularly where we have different size squares and rectangles and things like that, they're often used as kind of spacers or capping stones or various things around the layout. So very little actually gets wasted from the cutting process, which is great. Again, you can see some more pieces being inserted here. This is one of the little spacers for right on top, and again, where there are cutouts on our design, we can then nest some of those into some of those gaps again to minimise the amount of waste that we produce. But that's the general process. Once everything's laid out like that, then we will go through our process of framing all of this on our piece of wood, and then hitting play and then seeing what comes out. So here's a quick time lapse of the cassette being cut out. Obviously we can look at this on film. If you are doing this in real life, then make sure you do wear the appropriate eye covering. So this is sped up about 800%, maybe a little bit more. So I think this takes about 15-20 minutes to cut all of this out. Once that's cut out, we're going to take our base piece and we're going to use some copper tape, and we're going to put that on the bottom and roll that round onto the top side, where we're going to then fix our track. So next job is to cut our track to the right length. Here I'm just using a Dremel just to cut that down after measuring that, and that's going to fit right the way across the top of that base piece. So it's going to allow locos and rolling stock to run on at either end. Just filing the ends down here just to make sure we've got a nice smooth end on them. And then what we're going to do then is get that fixed on top. So you can see the copper tape on the bottom there. That's going to make contact with copper tape on our fiddle yards, and we'll see that in a bit more detail a bit later on. But then we're going to fix our track on top and then solder from the track onto those individual copper strips. So that's going to mean that we can feed power directly from underneath of our cassette onto the two rails, and that will then power any loco that's running on there. So to do that, what I decided to do was to get some little pieces of wire, attach those onto the track at both ends, just for a bit of resilience, and then solder that onto the top of those copper strips. So that keeps everything clear of the base, because that base is going to effectively sit flat and flush onto other copper tape on the actual layout itself. So I'm lining things up here. I'm then I've then got some neat PVA, put that onto the bottom of the track and just fix that down. One lesson I did learn was that this actually needs to be incredibly accurately done. To start with, I just used, I just measured and marked out some marks to where the stick for where to stick the track. I came up with a much more effective method a little bit later on, as we will see. But once that is dry, then we can solder those wires onto that copper strip. In order to make sure that dries well, I'm just putting a couple of clamps onto that, just to make sure that stays absolutely still while the PVA is going off. I found that PVA is fine for holding the track on here. Obviously, if we do ever need to take it off, then a bit of hot water will help to lift it, but hopefully we'll never need to do that. Okay, so here you can see a couple that I've got all set up and ready to go. Obviously, one of our criteria is being able to produce lots of these. So the laser cutter means we can cut sets of this out very, very easily. And then we can batch them up. So what I'm doing here is just checking the electrical connection between the copper tape and the rail to make sure that everything is connected up correctly before we go any further with the assembly. You could, for example, solder underneath the bottom of the rails onto the copper strip, but I found that this is actually a very nice way of kind of visually being able to see that you've definitely got a connection. And then it's just a question of assembling the rest of the cassette. So our two sides glued together with then some spacers on top, and as you can see, all clamped while the wood glue is in place and going off. And that is pretty much the assembly process. So a lot of hard work in the actual initial design, and a little bit of work involved in getting the track down, but then assembly and kind of repeating this process and getting lots of these things made is actually really, really easy, which meets one of our original criteria, which is great. And at the end of each cassette, to stop all the stock rolling off, very simple door system. So these are all 3D printed. Two basic sliders. So the idea is you have a door section, and that will, from the top, that will just slide down until it gets to the track, and then that will stop anything kind of coming out again. You can just lift that off. Not the best solution. I'm sure there's a more effective one, but that's a good starting point, I think. And when that's fitted, you can see that here. So these are just super glued on. And then it's easier when you're looking from above. You can just slide those on, and then whatever's on there isn't going to slide off as you're moving the cassette around about. Okay, so our loco cassettes. So this was very much a prototype design. After our experiences at the exhibition, there's going to be a couple of changes. First, I've already done, which is to drop a couple of spacing pieces in here. Now they've been cut to exactly the right size so that then the track can only sit right in the middle there. So initially I was measuring this by hand. That's just not accurate enough. So a couple of spacers, then the track just pops in the middle, and then every single time we build one of these, the track is going to be exactly the same place, which is going to really help. Okay, the other thing is I found that when gluing these together, it was hard to get them to sit exactly square, and getting them to sit square is really important to get a good contact when you put that down onto the copper tape underneath it. So I have built some little jigs to then use in the construction of the other ones I'm going to need. So just laser cut, and the idea is that I'll glue that together, and then when I build more of these in the future, then these can sit in here as they're gluing in order to make sure they sit square. So I will just get these glued up and I'll come back with the next step. So one thing we found at the exhibition was that loading up all the cassettes at the start was a bit fiddly, so we thought we'd come up with a better way of doing that. And a good way of doing it, we thought, was to create a railing device. Let me just show you what that's roughly going to look like. So we're going to have some track, again some spacers to make sure that's absolutely in the center, and then a railer. I'll talk about this in a second. Like this, and then you'd then effectively be able just to load your cassette up against this. Okay, so this is our rerailing device. I found this on Thingiverse. I'll include a link. You'll be able to see a screenshot of that now. So this is Cura. It is slicing software for the 3D printer. This is the software that takes your 3D model and turns it into the instructions that are going to be sent to your 3D printer. I use Cura. I've always used Cura. It's free. It's got great feature support, really intuitive and easy to use. And you can see here importing the railer into Cura. I have over the years set up various different profiles for the different 3D printers with the different hot ends and things that I have on them and the different materials I use. So I will just select one of those profiles to use with this. But this is a really simple model. There are no supports or anything like that. It's going to print really, really easily. But you can see here the process. You select all your options, hit slice, and it will then generate the code. It will also create a visual representation of what the printer's actually going to do, so you can then actually layer by layer just kind of slide up and down and just see what's going to happen. Just make sure that there are no issues with the model and that the slicing has worked correctly. This printed first time without any problem at all on a Ender 5 Plus. As you can see, there's no supports. It's pretty solid construction, and that's going to go on top of our base. Right, we have our base piece of wood and our two guide blocks put on. I've also stuck down some Code 100 track, removed the sleepers from this section here, and gone underneath it with just some offcuts of 2mm basswood. So with any luck, if we take our 3D printed railer and just offer that up, you can see that that's going to work very nicely.
So the ends of the rails are right up against the plastic, and again this bit of plastic's right up against that sleeper. So what I'll do is I'll just get that lined up, stick that down with a bit of glue, and then we can give it a test. Okay, so here is our railer glued down, and here is one of our cassettes, and let's test this out. So I can already see that the tracks are nicely lined up because of these blocks we've used to get the track around the middle. That's good. Let's pop a wagon on. Let that roll down. Okay, and it gets snagged on the wires that haven't been pushed back down again. Okay, so that was a failed demonstration. Right, let's try again. Perfect. So then the idea would be is we'd seal that up, and our wagon is now safe. And our cassette, obviously we won't be doing that to it, but we're able to kind of move that around in the fiddle yard. Excellent. I'm really happy with that. So there we go, a railer for our cassette system.
Okay, so one thing you might not have been able to visualize up to this point is how those cassettes are going to work on the layout in the fiddle yard itself. So let's have a look at the layout. Now this is the last board of Lambourn, so you can see the kind of the scenic section there that runs in through our scenic break and into our fiddle yard. Obviously we have very constrained space, so this was one reason for using this cassette system, that if we put any points in there, for example, we would run out of space very quickly. But from the fiddle yard perspective, it's very, very simple. All you do is put some copper tape down to match up with the copper tape on the bottom of the cassette, and then put those guide pieces in place. And then that is all of the engineering that's needed here. So in terms of reliability, it's really, really reliable. Because there are no moving parts, there's nothing to break. The power is fed onto that copper tape out of the way, so that when you put the cassette down flat onto that, the copper tapes make contact, and there is then electrical contact, and it's as simple as that. So what I'll do now is just pop one of our cassettes onto here. So this could either be a loaded cassette or one that we want to run some stock back into. Because of our block pieces, that's lined up perfectly with the layout itself. It will automatically get power. There's no need to connect anything up or flick any switches or anything, or remember anything like that. It really is as simple as just kind of drop in place, and it all works. So let's give that a go. Let's run a loco from the layout onto the cassette system just to see it works. And here you can see a much longer version that I made. You would have seen some of the designs in Tinkercad. So the great thing is that if you want to make a longer section or a longer cassette, you can just effectively bolt them together. Yeah, you can see on the top there some kind of cross pieces to make it a bit stronger. But again, with those kind of guide pieces in place, we can put any number of these in place here. So if we wanted to run a loco and a train in, we could do that and have them even then go onto separate cassettes and just kind of uncouple them in the middle. So here we can see a loco just kind of being run on to it. So the electrical power is taken from the layout. So everything runs very nicely across there. So in terms of our criteria, I think we've met all of our criteria. It's kind of really reliable. You can see the railer here just in situ. And there we have it. That's you right up to date with our cassette system and how it's operating in the fiddle yard on Lambourn. Now, what you'd have seen is that, or what you hopefully appreciate, is that we've been true to all of our design criteria. The system is very cheap to build new cassettes. It's operated incredibly reliably, particularly with some of the refinements that we've put in place. and it's also made operators' lives pretty easy so far. Now, I'm sure there are more refinements we can make to the system, and there are things that if we do, then I'll certainly come back and create an update video just to keep you up to date with that. But otherwise, I'm really pleased with how all this went. Hopefully you've learned a little bit as well about some of the process of kind of creating these things for yourselves. And hopefully that kind of mantra of kind of keeping things simple is something that you can kind of understand why we did that. And I think, as you say, as I kind of mentioned in the video, kind of when you look at the system, it's not much to look at really, but it works incredibly effectively. And I think that's kind of one of the keys. Okay, so I'll be back again with another interesting topic in a video soon. So I hope to see you all then, and bye bye for now.